All right. Thanks, everyone, for coming out today. So my name's Jared Parsons, and today we're going to be talking about nullability in C#8. So a quick bit about me. I've been working on programming languages at Microsoft for about the last 13 years. Presently, I'm the developer lead on the C# compiler team and a member of the C# language design team. And the difference between those two teams is essentially the language design team is the one who kind of sits down, they design the features, and roughly set the direction for the language. While the compiler team is the ones who make all of those ideas a reality and produce a shipping product for our customers to consume. So we're going to be talking about nullability today, but before we get into the actual feature, I want to talk a little bit about how we kind of got to this design of nullability. Support for null safety is something that customers have been asking for us from about a decade, and it's something we've always been very interested in adding. But how do you get from the idea of adding null safety to the language to an actual implementation that customers can consume? Now, because I'm doing a talk about null references and programming languages, I've been told I'm pretty much contractually obligated to make a reference to the billion dollar mistake quote by Tony Hoare. And for any of those unfamiliar, Tony Hoare is generally the one who is held responsible for introducing null references into programming languages. And he calls it his billion-dollar mistake because that's how much he thinks it's kind of cost the industry. And if anything, that's a gross underestimate. And what we're trying to achieve with null safety in C# is essentially removing that mistake from the C# language. Now, kind of the starting point for this journey is C# 7.3, which has no support for null reference tracking. Instead, developers are just kind of asked to follow a set of best practices. Read the API documentation, hope that it's up to date, and hope that it's very clear about where you can pass null and what can return null. In cases when there's no documentation, make sure you guard all the return values and check everything for null and just be as good of a citizen as possible. And also, make sure you allocate a lot of time to kind of fix all the crash reports you're going to get for null references in your code. And so, in C#8, we want to fix this. But how do you add null tracking to a language that's 20 years old? And this is an important distinction because when we talk about adding null safety to C#, we're talking about extending a language, not creating a new one. When you're creating a new language, the door is wide open for how null safety can be introduced. For instance, you can take an approach very similar to what F# does, where you embed null deeply into the type system. You have match expressions, you have option types. It's a green field, and you can pick pretty much any solution that fits the style of the language that you're creating. C#, though, it's an established language, and that kind of narrows your possibilities. There are 20 years of features in the language that were never designed with null safety in mind. And there's also 20 years of C# code written by millions of developers that use essentially the same standard set of null checking patterns. And if you pick a very invasive solution, like really altering the type system, it can really dig into those patterns and change the look and feel of the language. And that can create something that's unfamiliar and unpalatable for developers. And so, let's kind of take a deep dive into a couple of those types of deep changes you would make and see why it kind of creates a bit of friction. So the first one is what if you added a perfect type system to C#? And what I mean by perfect here is that you have distinct types for nullable and non-nullable values, to the degree that if you have a non-nullable type, you are pretty much guaranteed at runtime that that will not be null. And if you dig into the history of C# here, you'll find there are actually a couple of variants of C# that have done exactly this. The most notable of this was probably Spec#, which was produced by Microsoft Research around 2000, in the early 2000s. And there were a couple of other projects, but they were mostly kind of Microsoft internal ones. And what you'll find when you look at these is they were actually really successful. They created a type system that was very good at eliminating nulls. However, they received almost no internal or external adoption. And the reason why is because those languages no longer looked and felt like C# anymore. I mean, there are just too many features in C# that just fly in the face of null safety. For example, array creation. That's going to default to putting null in all of the element values. If you call methods in your constructors, which pretty much everyone does, That can subvert field initialization. You could end up accessing fields before they have a value and generating null references. Default of T in generics, that's just another way where null just kind of gets piped into the language. And these are all features that C# developers, they take for granted. But if your goal is perfect null safety, you pretty much have to remove them from the language. And that meant the resulting languages, they're going to be safe, but C# developers, it's just not going to look like C# to them anymore. And I was actually a part of one of these internal experiments. And so I got to see firsthand the struggle with C# developers trying to adopt the languages that we created. And it frankly really turned me off to adding null safety ever again. To the point when they proposed adding null safety in C# 8, I was like, no, we're not doing that. It's going to fail. And it wasn't until Mads Torgen, our lead language designer, kind of sat me down and walked me through his vision for kind of getting away from perfection and kind of instead saying, hey, let's accept the history of C# and let's create a solution around it, that I kind of started to get behind this as an idea. Another solution people bring up is, why not just add a new type? Why don't we go add optional T to the framework, where this is essentially nullable of T, but for reference types? And this means that just by virtue of the API, developers are going to be protected from null because they're going to have to do things like get value or has value before they can do any operations. And as a bonus, this requires no language changes, so we can free up the compiler and language team to do all kinds of other good work. This solution ends up having a number of problems, though. Firstly, this does nothing for all the existing null handling in people's code today. And frankly, in order for people to adopt this solution, they have to rewrite their code to use this new type. So it's a big adoption cost. And whenever you switch a parameter, for instance, if you change a string to be optional of string, you've actually broken binary compatibility for that API. And for a lot of customers who have deep compat concerns, that's a non-starter. And kind of the worst part about this is this actually introduces just yet another null, yet another type of null into C#. And so that's something else you have to train developers to work with. So this kind of idea, it does nothing to solve existing problems with null. It adds a new kind of null to the language, and it risks binary compatibility. So this is something else that just is generally not palatable as a solution. And when we kind of look at these failed experiments, we can kind of start to get an idea of what would a successful solution look like in the language. And the first one is, we really need to focus on maintaining the look and feel of C#. This is not really special to nullability. This is something we think about for every feature we add to the language. However, when we start designing nullability, this seems to be one feature where people are very inclined to say, well, maybe this time we could change it. And the answer is no, you can't. Secondly, we need to make sure that we add value to the existing code out there. We can't be asking developers to say, hey, we need you to take all that code you've written, we need you to move it to a new set of types and a new set of nulls, and then we will improve the null safety of your code. Instead, we need to find a way to make the existing null checks and patterns in people's code more effective. And lastly, we really need to embrace the imperfect history of C#. There are 20 years of features out there, and while they weren't designed for null safety and maybe they're not perfect, they're also in high use and they're highly loved by developers. We can't ask developers to throw away all the things they love as a trade-off to getting better null safety in their programs. And so another aspect that we have to keep in mind is the size of the code bases that our customers produce. Generally, we think of the code base in terms of small code bases, which are a little bit less than 10,000 lines of code, all the way up to jumbo code bases. We were talking about over 1 million lines of code. And these large and jumbo code bases, they're not uncommon. If you look at the Roslyn GitHub repository, where we have the C# compiler, we have all of the Visual Studio integration, you will find that it's about 5 million lines of code all told. And this is not the only .NET GitHub repository that's 5 million. CoreFX and CoreCLR, they're about the same size. And if you go and look at ASP.NET Core, you'll find it's a little over 1 million lines of code. And further, this is not just a Microsoft thing. It's not just Microsoft creating these giant repositories. When we work with our customers and kind of do deep dives on their solutions, we also find similarly large solutions that they are creating. And we need to make sure that whatever solution we design is usable in all of these different code bases. And what that kind of means as a practical application is that we can't assume that customers are just going to enable nullability on their entire code base in one pass. In fact, we have to assume that that's not possible at all. Because when you look at the cost of adopting nullability, really no matter what solution you choose, it's going to be proportional to the size of the code base you're applying it to. Enabling it in kind of a medium-sized code base, we're talking about like 100,000 lines of code, you're generally going to be editing somewhere between 50 and 100 files. Once you get up to large or jumbo code bases, like you can end up changing thousands of files in order to do like a full nullability pass. And just consider for a moment what it would look like to create a pull request for your coworkers to review that was 1,000 lines of code. First of all, GitHub's not going to display it. GitHub really starts limiting pull requests at about 100 files. Once you get up to 1,000 files, the UI is going to be kind of significantly reduced. If you get a UI at all, you're much more likely to see the unicorn of death, which was very common for us when we tried some experiments. and worse, your coworkers are not going to thank you. Like sending a pull request which is 100 files, like you might get away with, but 1,000 files, you're talking like multiple days of review, even weeks, and the change is mostly just adding question marks and if checks. Your coworkers are not going to be very pleased. So the only reasonable solution we have here is design one that can be incrementally adopted. We need to give developers the tools so that they can go and add null safety to a single component, maybe a directory, or maybe even a single file. That means that they're creating these small, single-focused PRs for developers to review. And while these individual changes aren't going to fully enable null safety in their code, every one of them is going to make the code incrementally better and be one step closer to full adoption. And lastly, we have to think about the .NET ecosystem and all of its libraries. If you look at NuGet alone, we have a couple 100,000 libraries out there. And when we think about kind of more proprietary or private companies, there's probably an order of magnitude more libraries to think about that we're just not aware of. And it's not just realistic in this broad ecosystem for us to just wake up one day, snap our fingers, and everyone to have enabled null checking in their code. It's going to take a significant amount of time for even the majority of the highest used libraries to kind of get to full nullability. And developers, they don't want to wait for that to happen before they start embracing null safety in their code. When we release nullable support in the compiler, they're going to want to use it immediately. They don't want to wait 1 to 2 years for all the libraries they depend on to turn on null safety. And further, we kind of have to accept that some libraries are just never going to have null safety enabled. Either the developer who owns it just doesn't believe in null safety, maybe they're not actively maintaining that library anymore, but it's still used by developers that are passionate. And so that means we have to design a feature where developers can enable null safety in their code and still be productive, even if none of the libraries they consume have ever added null safety. And so with that in mind, let's kind of talk about the solution that we created, non-nullable reference types, also known as the last 2 years of the C# team. And I'm actually quite serious when I say the last 2 years. This is easily the biggest feature that we added to the language since generics. And that's because, like generics, this touches everything: declarations, expressions, conversions, metadata. We actually tried to see, if it was bigger than generics. Unfortunately, there's no one left on the team who added generics, so we couldn't find anyone to really ask. And further, this cost actually spread outside the compiler team. Like the BCL team, they had to spend a lot of time getting annotations in the framework. We had to get a lot more Visual Studio support. It was overall a giant undertaking. Now, the rest of this talk, I promise, is going to be very demo-focused, but I want to kind of talk about the principles of our solution here because I feel like it adds a lot of context to the demos you're going to see. The first is that non-nullable reference types are the default. So all the strings and objects that you've already added into your code, when you flip on null safety, those are going to be considered non-nullable. And that's because values, not the lack of values, are the more common case in programming, which means that non-nullable should be the natural default. And secondly, continuing the theme, we're going to maintain the look and feel of C#. And part of the way we're going to achieve that is by using the question mark to annotate nullable reference types. So this was already the syntax for nullable value types. And using the same syntax for nullable value types and nullable reference types keeps the language simpler and provides the same look and feel for the same problem space. And so also, we have to leverage the existing null checking patterns in C# code. I mean, nulls are a reality in C# today, and the majority of code out there handles them with a common set of patterns: if checks, throw helpers, switch statements. And the compiler needs to recognize those and learn from them. If you check a value and say, if this is not null, and then immediately on the next line access a member on that, and the compiler gives you a warning, that's a failed solution. And lastly, we don't want to impact runtime or semantic behavior here. Instead, we're going to provide guidance to the developer through warnings. And we want developers to annotate their code knowing that the annotations in themselves are not going to change programming behavior. As we went over, perfect solution is just not possible in C#. So the idea of changing runtime or semantic behavior based on this imperfect solution would be a very dicey proposition. It's also very dangerous. It would likely result in developers being a bit more hesitant to adopt the feature and overall increase the cost of doing so. Instead, we want nullability checking to be a tool to guide developers to the places where they fail to do the proper null validation, and then they can use the existing patterns they're familiar with to make their programs safer. Now, so with all that out of the way, let's get to the fun stuff. All right. So firstly, let's talk about how to turn on null safety in your code. There are a couple of ways of doing it. The first one is the big hammer. I want to have nullability enabled in my entire project. In order to do that, just open up your project file and add a new property and spell it correctly. So essentially, adding nullable enable here will then turn on null checking for my entire library. And if you want to have directory pops files, you could do it for your entire solution. As we said, though, that's kind of the big hammer. That is one where when we do it, that is going to be very impactful. When we think about some real-world examples, so that the core library of the compiler, Microsoft Code Analysis, it's about 175,000 lines of code. When we did this as our first shot, we got about 3,500 warnings, so a little almost 4,000 warnings, and it's just not approachable. Instead, though, the more granular solution is to use the nullable directive. So I can go into any file in my program and say nullable enable. And what this does is it's very similar if you've used Pragma before to Pragma, whereas it's a lexical directive. So from this directive down and the rest of the file, the compiler is going to begin to give me nullable information. And as you can see, it's already started to give me a few warnings in this code. For instance, it said here, hey, you have a non-nullable string, and you don't have a constructor in this type, which means that you never gave this a value. So you either need to make this a nullable type or create a constructor that's going to fix this. Also, if we start to look a little bit further down, we can see that we have a simple try-get pattern here where we're getting a value out of a map, and the compiler is warning us that, hey, if I look at the try-get value API, it says that this can return null, potentially, but you have given it a non-nullable value. Are you sure that that was the right answer? And then down here, it's actually spotted another potential bug in the program. The compiler has recognized that up here, we potentially assigned this a null value. And without doing anything else to the value, we are returning it to our consumers. And this is now a potentially null value. We've promised to be non-null, and the compiler is smacking us down for it. And as I said, this is a lexical directive. So if I were to take this and move it just a little bit further down the file, you would see that I no longer get any warnings for this type up here, yet I still get all the warnings below it. And this is how you can kind of use this directive to kind of very fine-grained apply nullability into your code base. And this is actually how we've been applying it into the C# compiler. And so far, in some of our more common DLLs, this pattern of just putting nullable enable at the top of certain files, we've gotten to about 1/3 coverage. Now, let's talk a little bit about annotations and how they kind of impact program behavior. So here, we have a couple of methods, one which disallows null, and it does so by just taking a normal string type, and one which allows null by essentially saying, I accept string question. And here we have we have a little method. It has a non-nullable string, and you can see that it can be used in all the cases. It can go to places accept null, places don't accept null. I can invoke methods, everything's fine. But the moment I try to assign a value, the compiler, nope, that's an error. Now, let's take a look at what happens when we switch this around and say, let's make it a nullable reference type. Now you'll see the compiler is giving me some great feedback here. It said, you're passing a potentially nullable value to one that does not accept null. And also, you're invoking a member here. You're saying that this is a potentially null value, and you're calling a member. This is a bug in your program. And further, the assignment to null now is just fine. Now, let's take a look at some generic code. So you can see here the compiler is once again spotting that I have a list of non-nullable strings. And it's happily warning me that, hey, you're assigning null here, this is wrong. But in all other cases, I can use this value. Now, what happens if I say that we have a list of nullable strings? So this is a list that will never be non-null, but the elements within it can be null. And so now you'll see that the null assignment is fine, but invoking a method on one of those members, like, that's a warning, because that's another place where I potentially have null in my code. And also, the compiler is giving us another warning down here. It is saying that you have a list of nullable strings, but you're assigning it a list of non-nullable strings. And that's just a basic type incompatibility. You get the exact same type of feedback if you use an int question mark instead of a string here. And once again, we can fix that by adding a question mark. Now, one of the other things I talked about earlier is, like, this is an imperfect solution. Like, this is essentially the compiler looking at potential warnings and giving you guidance. And because it's imperfect, it's going to be wrong in certain cases. And there are times the developer is going to have to say, trust me on this one, I know what I'm doing. And the way you can do that is essentially by applying the null forgiving operator, which is essentially exclamation point. I like calling it the trust me operator. That did not make it into the spec. And so what you do here is essentially applying the exclamation point at the end of the expression tells the compiler, trust me, I know what I'm doing here, just pretend that everything is okay. It's okay to ship that way. So now let's talk a little bit about that mixed ecosystem problem. That problem where we have code which is nullable enabled mixing with code that is nullable disabled. Now, generally we like to think about this as libraries. Like, I'm referencing a library, it doesn't have nullability enabled, what do I do? But really, this problem applies to any pieces of code where you have that mix of nullable enabled and not nullable disabled. So we can use this directive within a file to have assembly1, which is disabled, and assembly2, where we have null safety turned on, and get a sense of what that behavior will be here. So you can see that I'm calling into the identity function, and I'm passing null. However, when I look up here, this is still using a non-nullable object type. But because this is not annotated, the compiler essentially falls back to the following logic. It says, if I'm dealing with an API that's not annotated, essentially trust the code that is. And what that means effectively is that you can pass null. If you pass null, the compiler will be like, well, that's probably the right decision. And it will also assume that any return values, any method you call is always going to return non-nullable values. Now, we ship this way. The author of assembly1 wakes up, decides to enable nullability one day. And so he enables nullability, and then they go through and say, okay, this is an identity function. So what is I should accept and return null values. So the proper annotations here are to essentially take object question mark and return object question mark. Now what you see is the author of assembly2, they update their library, and then suddenly they get a new warning. And what they found out that was, while it was okay to pass null here, it was wrong to assume that non-null was what was returned. And so by simply following the warnings, they put the question mark there, say, okay, this is potentially nullable, and then now the compiler tells them where the bug was. You are now, what we're looking at here is a potential null reference in this code by calling on a member where it's potentially going to throw. Now, all right, where are we? Yeah, good times. So next we're going to talk a little bit about constructors. So we have a very simple object here, name. So we have first, we have middle, and we have last. And so when we enable nullability, and as you saw before I did this, there were no warnings in the code, everything was beautiful. So I add null checking, and immediately the compiler gives me a little bit of feedback on name. It says, hey, you have a constructor here, and you have a bunch of fields that are all one of those non-nullable fields, you didn't assign it a value. That means it's going to have null. And so in this case, it's just because I've commented out this the assignment of last. And when I remove that, the compiler is happy, and it tells me that this constructor is fine. But now it's giving me some feedback here saying, well, that other constructor where you decide that middle names are optional, you're passing a null value to a non-nullable. It's like, OK, great. So let's go ahead. That was the goal here. I wanted to say that middle names were optional. So let's kind of express that intent, put the question mark here. Now the compiler is going to tell me, well, you're missing one here. And so now this object is correct. This object actually expresses the intent I meant when I designed it. But when I scroll down, you'll see the compiler is now giving me a different warning. It says, hey, that middle name that you're accessing, the author of that type said that that can be null. And if you kind of follow the logic out here, this will null reference at runtime. And so now the compiler, just by merely expressing the actual intent of my API, the compiler is giving me actionable places where I might have bugs in my code. Now, the problem with annotations, though, is if you have annotations by themselves, it's just not enough. And the reason for that can be demonstrated by this sample here. I have this function. It's basically trying to get the user data for a given ID. But the ID is optional. If you don't give me an ID, I'll just give you the default. I'll give you the user data for the default ID. And so this is very simple. I check the ID for null, and if it's null, we give it a default value. And this default value is always a non-null value. But here, when I access this map to produce the value, I'm having to use the null forgiving operator again. And that's because the type of ID here is string question mark, but the map is over strings. And so if you just think about this from a type system and annotation perspective, I'm passing a string question mark to something that takes a string. That's wrong. Like, the compiler is going to flag you for it. But let's look at what happens here if I delete that question mark. And you'll see that nothing happens. The compiler actually doesn't complain about this at all. And that's because the compiler has looked at the code here and determined that even though ID was specified as a nullable type, by the time we get to this line, it's a non-null value. And that's what the compiler is doing, is it says that, oh, look at this if check. This if check is looking at null. So in the case where the value is null, it's assigned a non-null value. And hence, by the time we get down here, it's a non-null. And we can actually play with this and see just how powerful the flow analysis tracking for these local variables is. So imagine I go here and type id.toString. At this point in the program, the compiler is still going to give me a warning. It's going to say, hey, this is still a potentially null value. You have done the wrong thing. And if I take it here, put it below the line, you'll see the compiler is happy. It says, oh, at this point, I know that this is definitely going to have a non-null value. And we can go further. We can even open up an else block here, and we can do the exact same thing. You have to spell correctly. That's a big problem. And you'll see that once again, the compiler is not going to give me a warning here. And that's because it's determined that if we get to the else block here, that's only going to happen when ID is not a null value. And this flow tracking is really, it's a very fun thing to play with. So as we said before, if we put this above here, we get a warning. But if we do two method calls, if we do id.toString and do the same method call again, you see the compiler is not going to give us a warning for the second one. And that's because the compiler said, well, if it was null in the first call, it's going to throw an exception. So by the time I get to the second call, it's definitely not null by now. Please don't ensure null safety that way. And this flow analysis that we used to use for definite assignments and refactorings in compiler that we now use to track null state, it's not just limited to locals. It's actually extended to track properties and fields as well. So as you'll see here, we once again have a first name, middle name, last name. Middle name is, nullable string. And you'll see that, as expected here, we essentially dot through middle name, and the compiler says, yeah, this is potentially null. But just like with the locals, we can remove this warning by just doing a null check for middle name. And the compiler now says, applies the same logic does to locals to those fields and properties. Now, and this is one case where having an imperfect solution is better. If we were doing a perfect solution, this would not work. And that's because properties, they're really under the hood just method calls. And we have to kind of assume that every time you call a method, something happens. It's mutating some state. You're not necessarily going to get the same answer every single time. However, if you look at C# code and all the patterns people do, this is one of the patterns they do. They assume that properties are non-mutating and really act like fields. Now, we do not apply the same logic to method calls. So if you look up here, we have the get middle name, which is the exact same code as the middle name property, just in function form. And if we add the same check, and wait a second, you'll see that the compiler never actually removes it. It keeps the warning there. And that's because even though it's basically the same code, the compiler kind of draws the line between method calls and properties. And it says, I can't assume that the method call will return the same value, therefore, this is not going to work. Now, this flow analysis is not just limited to kind of if statements. We've actually kind of plumbed this through every part of the C# language where there is actually kind of control flow and state to track. And in this example, you're going to see we have this dinky function which is going to take this object and print it as a number in all kinds of various incorrect ways. And so this is a potentially null value. And we start with the switch statement, and we say, OK, in the case that it's a string, just parse out the number and print it. And you'll see that we didn't have to say string question mark here. We said string. And that's because the compiler knows that the only time that this is going to be hit is when it's a non-null value and the type is string. And further, we can now do things like invoke methods on data, because the compiler knows that to get to this code path, data had to be non-null. As opposed to when we look at the bottom here in case var, this is kind of the default in pattern matching and switch expressions. And this is a valid target when data is null. And so you can see that the compiler is saying, hey, v is potentially null here, and you're invoking a method. This is bad. But what if, instead, we handle null directly? We just have a piece of code here. We say, hey, in the case this data is null, fall through here. Now the compiler has kind of removed this warning for v, because we know that when it's null, it's going to flow here. And that means that case var will only be hit when data is a non-null value. Now, it goes even further. As you see down at the bottom here, we're getting a warning on invoking kind of a method on data, because the compiler says, hey, data is non-null. If you get here, it's going to be null. What if we take this break and change it to a throw? You'll see pretty much immediately the compiler removes the warning for the data.toString at the bottom. And that's because just by following the flow of the program, it can see that when data is null, that it's going to throw an exception and exit the function. And by the time we get to this toString call, it's always going to be a non-null value. You'll also see the compiler has helpfully said that throw null is a problem. Because if you throw null, it will throw an exception, but it will throw a null reference exception. All right. So as we can see, like the compiler has it's basically taken all the features in language that kind of have control flow and affect the output program and applied its knowledge of those constructs to give the customer the best possible outcome. But what do we do about API patterns? If we look at kind of any medium-sized code base to large, we find over and over again that they have all kinds of helpers for throw if null. They have essentially something equivalent to contract requires, try get assert, or try get value. And all of these functions, they add null information to the code base. And for instance, like when we started making like the .NET code base, when we put all the annotations into there, we found these helpers everywhere. And the feature was really incomplete because all of this kind of information about the flow of the program was there, but the compiler couldn't do anything with it. It can't look at a require function and tell the difference between require and console.writeLine. It's a method, it takes a parameter. Who cares what it does with the program? But if we kind of look at this program, we can see that in the case requires is false, this throws an exception. And then we look here and we say, hey, the only time if address is null, it's going to be requires false, the program's going to throw. So that by the time we get to this writeLine call here, like address is never null. But the compiler doesn't intuitively know what this means. So the way we solved this is we added a set of attributes into the framework that the compiler recognizes, where you can put these attributes on your methods to give the compiler information about how it impacts the flow of the program. And for instance here, what we can do is we can add a function called does not return. And what this tells the compiler is, hey, if this parameter is false, this function doesn't return. Either it throws an exception, it has a while loop that never terminates. And now the compiler immediately removes the warning on using address.name. It's because the compiler, we have connected the dots for the compiler. We have told it what the behavior for requires will be in the case that address is null. And the compiler has happily responded by saying, great, by the time we get to this write line call, we know that address is non-null, and this use of is safe. So another real common pattern in .NET is the try pattern. So you either have try parse, you have try get, and this is all over the framework and user code. And this is another place where we kind of need to connect the dots for the compiler. But it's a little more complicated. And so the attribute that we use here is essentially, we can go to this address value and say, that this value here, this out parameter, which is correctly has to be a nullable reference type, this will be non-null when the return value of this function is true. And so now you can see the compiler, once again, has happily removed the warning. It has said that when this is, when this is true, we will, by the time we get to here, the return value try parse was true, and hence address is non-null. And contrarily, if we try to use address.toString here, the compiler will respond by telling us, yes, this is a potential null value in your code, and you need to fix this. Now, so my other kind of favorite, so this is actually, this particular demo slide I stole from a coworker, Drew Noakes, because I saw a presentation he did on Nullable, and I thought that this was such an awesome example of how framework annotations benefit. He allowed me to use this for my talk. So what we're going to see here is a bit of a pop quiz. So we have a series of path functions here. And if you look at them, it's get directory name, get file name, get the full path, get the root. And what all of these are doing is they're taking a path on disk, and they're saying, give me some piece of it. Either give me that file name, give me the directory name, give me the root. We're not actually talking to the file system here. This is just basic string manipulation. And you might look at these functions as a whole and say, well, surely there's a pattern here with null. Surely the person that wrote all of these functions either made one of two decisions. Either null is a valid return or null is not a valid return for these API calls. But what's the right answer? We can find out now by enabling nullability. And what we find out is get directory name and get full path root can potentially return null, while none of the other functions do. So the answer to what was the plan here is there wasn't one. It was a collection of individual decisions that was made by the particular library author at the time. This was actually a point of consternation when we were kind of adding null annotations, where people were getting these warnings and they were filing feedback on the framework team saying, hey, you did this wrong. And the framework team would then point out the code. It's like, no, look, like right here, we definitely return null. Like, that's not a joke. And then maybe you're saying to yourself, okay, well, if there wasn't a plan for the collection of APIs, maybe there was a plan for the inputs. Maybe there was some consistency on whether null was a valid input or not. And if we comment this out, we can see very quickly that, once again, there is no plan. There is essentially, there's not even a correlation between the ones that return null and accept null. Like, it's just basically random. And before this feature, before we had nullable reference types, there's almost no way we could expect a developer to get this right. You can really only get the right answer here if you went and read the .NET source code. And I'm not sure a lot of people do that, and even people who did it often missed some of the cases where this could happen. But now, with nullable reference types, like, this is just free. We've done a lot of work to get the framework annotated, and just by turning this on in your code, you get this value without any additional research. No more going to MSDN, no going to the source code if that's what you preferred. Now, so for my last demo, this is my favorite one. So what you're seeing here is actually a pull request into the C# compiler. And what happened here is we had a customer who decided to mix dynamic and nullable. And what ended up happening was they got a null reference exception in the compiler. And so we said to ourselves, this is a great opportunity. If we enable null checking inside the null reference implementation of the C# compiler, will this tell us where the bug was, or do we have to search further? And so as you can see here, we did kind of a very strategic insert of nullable enable. And then if we scroll down just a little bit, we see the bug. There was a path in this giant blob of code that we've kind of hidden here, where constructor turned out to have a null value. And this is where the compiler was crashing and getting the exception. And by adding this to the nullable enable to this very short amount of code, the compiler immediately told us where the bug was, and then the developer went through and just did standard C# code to fix the problem. So basically, this is a pull request where we're using nullable tracking inside the nullable reference implementation of C# compiler to fix a nullable bug. It's like the most meta PR that we had in this entire feature. All right, so right about on time. All right, so getting back. Yay. So quick review. The question mark annotation is what allows developers to kind of express their intent around null, just as you would do for nullable value types. And the compiler is going to recognize and learn from the existing null checking patterns in your code base to give you the best possible experience. And all the time we've taken to get those annotations into the .NET framework is just going to be pushing your code to better null safety. Now, we're going to close talking a little bit about the state of nullability in the .NET SDK. So looking at kind of .NET Core 3, where are we? So we shipped C# 8, and this has support for nullable reference types. The .NET SDK itself is partially annotated. So corelib, which is roughly the equivalent of MS corelib from desktop, is fully annotated at this point. That's about 10K methods that we ended up touching. The rest of the SDK is largely unannotated. That's more of a point-in-time problem. As I said before, nullable reference types is the biggest feature we ever did. So we got that implementation to the framework team about 3 months before we shipped, and told them that they had to go and fix the entire SDK. They told us no, that we'd fix part of it, and we'd do the rest later. The .NET ecosystem as a whole is partially annotated. If you look at some of the more popular libraries, you'll see that the authors are starting to adopt this feature and go forward, like Newtonsoft.json is one who started to make some progress here. Visual Studio Threading APIs have some PRs out for it. The .NET Desktop, though, is not annotated and will not be. So this is more of a .NET Core thing going forward. So in terms of .NET and the nullability in the future, right now we're in kind of what we call the rollout phase. The time between .NET 3 and .NET 5 is when we at Microsoft are focused on getting the rest of the .NET SDK annotated. So the parts of the SDK that we plan to ever annotate, we're going to do it in this time period, with goal that by .NET 5, we're kind of done with all of our legacy debt, and all the future code that we add, we will be adding with nullable enabled. And our goal is that in the same time frame, we're hoping to push the ecosystem in the same direction. Have everyone turn on nullable enabled, get your libraries in the same phase, so that when we go to .NET 5, we kind of enter a fairly steady state for the rest of the ecosystem to adopt. And this does mean that if you're kind of an early adopter, if you're someone who's turning on nullability now, there may be a little bit of new warnings as you upgrade libraries for the next year or so, but this is going to be proportional to the APIs you consume. And the warnings are going to be telling you, this is where you were wrong. This is where your code is not null safe. So it's the feedback that you wanted to get, just slightly delayed. So, and kind of as a recommendation for library authors, like let's say we really want you to annotate in this kind of rollout phase. And if you're someone who is currently targeting .NET Standard because you're trying to get like the maximum reach for your library, our recommendation is to kind of switch to a multi-targeting approach. Target .NET Standard 2.0 so that you continue to get that reach you were getting before, but also target .NET Core 3 and enable nullability in that configuration. That way, you get the feedback from the framework annotations. You can add the best nullability possible to your code. And if you disable nullability on the .NET Standard 2.01, you can continue to ship there, keep your reach, you can get the best null safety possible, and be in a great place moving forward. Now, lastly, I want to talk a little bit about adoption strategies. So if you're a customer out there thinking about your code base and like, how can I, like, what do I do? Like, I have a code base of this size, how do I get nullable enabled? The first one and the simplest one is just annotate everything in one pass. Go to your project file, turn on nullability, fix the warning, send a PR, buy your coworkers a beer for reviewing all of that. I would strongly recommend, though, limiting that to about 100 files. If you get above 100 files, you're going to have a lot of problems kind of getting your coworkers involved in the process. Instead, chunk it up into smaller reviews. Another strategy, if you have like a bigger code base, is to just go in dependency order. Essentially, think about your projects, like what is the rootmost project in your solution, and go make that nullable enabled however you can. And then once that API is fully enabled, move to the next layer of dependencies. And the goal here is that when you start with adding nullability to a particular project in your solution, you know that all the code that you referenced has nullability enabled too. And this is actually the exact approach that the .NET SDK team has taken. And it's been very successful for them, and they are well on their way to hitting their goal of full annotation by 5. Another kind of more simple and basic approach is just annotate files as you change them. This is actually something the C# compiler and IDE team decided to do. We added a very simple rule. If you send a PR to fix a bug, great. Go add nullable enable to the top of every file that you changed, and do that as a part of your bug fix. And what that does is it keeps your kind of annotations in small reviewable chunks. It also means that you're focusing on the active part of your code base. That stale part of your code base that everyone has in a big project that never changes and it doesn't have bugs, or the bugs just don't show up because it's not hit. You never actually waste time on that. Instead, you're focusing your time on the part of your code which is the most active and under the most development. And this might seem like a very simple, like basic strategy, but I was super surprised by the results. When I was kind of preparing for this talk, I wanted to get some stats on how far we had gotten, and I found that kind of for the most important parts of our code base in Roslyn, we're about 1/3 of the way to being fully annotated. And we're talking about a 5 million line code base where if you look at the C# compiler on its own, it's about 700K lines of code, and we're about 1/3 of the way there now. And just with this very simple rule and a couple months of changes. So, and this slide is more of a resource slide. I kind of have some links to a bunch of different pull requests which kind of demonstrate each one of these different strategies. And so a couple more resources for you. These are some great blog posts about kind of what the nullable reference feature is, taking it for a spin in some code bases, and some other further reading. I talked to you about attributes early on. I demonstrated 2 of them, the not null when and does not return if. There's actually about 8 total attributes that we added that you can use to kind of improve the feedback to the compiler. All of the information for those are kind of linked here, as well as some really good demos for each of them. All right. Well, thanks everyone for attending. And I think they said we can use about 10 minutes or so for any questions that people might have. All right, so anyone have any questions? Everyone understands nullability, it's great, it's perfect. All right. So we get a mic up in the front. Oh, you can go.
Hello. So how many bugs have you found because of introducing the nullability?
How many bugs have we found in our code base?
In your code, yeah. Does it mean you found some, or was it all perfect? You just added it? And
it's actually a great question. So if you look at like there were different results in different code bases. For instance, if you look at kind of the core effects repository, so that is kind of the .NET SDK. That's where you have like int, system not threading. They actually found a very few number of bugs. And the reason why is because literally everyone here is using them. If you have a .NET program, you have used their code. And just by virtue of all the developers in the world using them, they have found every combination of terrible ways to use it and then fixing the bugs. Now, as opposed to like Roslyn, where we don't have quite that combination, it's much more of kind of like our in-house usage with analyzers and some other tooling. We actually have found a lot more bugs with that. I don't have a good number for you, but I would say kind of offhand, probably every 3rd or 4th file that we turn this on, we find either a bug in the code or a bug in the compiler. who's next?
You mentioned the default operator in the here.
Okay, next.
You mentioned the default operator at the very start of the session, but actually you didn't cover it, I believe.
No.
So enabling nullability does change the behavior of this operator.
Yeah. So enabling nullability will change the default operator. And actually, this is one where the way we kind of solved it in kind of the initial version of nullability is we said that, hey, this is, we just kind of give people warning saying, you're using default of T, this might be bad. However, we actually we did that, and we got a lot of feedback from users, and they kind of showed us all the scenarios where this was causing them problems. And right before I got on my plane to come to this talk, we actually had a proposal sent to the language design committee on how to deal with default of T. And it was essentially embracing the flow state of the compiler. And the same way that we kind of use null checking today, we said, let's have default of T essentially have this maybe state. Maybe it's null, maybe it's not. We have no idea because we don't know what T is if it's unconstrained. And what we do is we wait for you to try to use it. And if you use it without assigning something which is definitely not null, then we're going to give you a warning. But otherwise, if you just create defaults of T and return them, then we will give you nothing. And that really reduces the friction of using them. And it's probably the best middle ground for how to deal with that problem. Okay.
Thank you. Great session.
Thank you.
You mentioned how actually initializing fields works and while using nullable. But while using nullability, when initializing properties, the compiler did not warn me about keeping some property null, even if they were stated as non-null. Is that true, or is it actually something that's not finished, or am I using it wrong?
I'd have to look at your example. There is a little, like constructors is definitely one of like kind of the tension points in the compiler because we have to kind of deal with the fact that constructors are just inherently unsafe. And with properties, they kind of blend the difference between like method calls and fields. And so you can get into a question of were they initialized elsewhere, or is it something that we have to definitely initialize in the compiler? And there is a bit of a difference between generics and non-generics. But if you have a specific example, I can help you through it afterwards.
Thanks.
Okay.
Hello. So you showed us that we can use attributes or methods to give compiler hints whether some values may be null, maybe not null, and so on. But that's also a possible source of error, right?
Yep.
So could you do some improvement that would show us warnings when the compiler knows that the attributes are incorrect for that code?
I think that it would be hard for the compiler itself to do that because the compiler is kind of already doing, like, nullable is already an extremely computationally expensive problem for us, like calculating all the flow state. And the problem for us is really, like, when we look at a method, when we look at method calls and we're analyzing them, all we can really do is look at their declarations and say, this implementation promise, this is not null if this is true, and therefore we will do this. Adding the extra check to basically say, is this good, or like, did they tell us the truth or did they not tell us the truth? That could be done. Like, and it's something that, like, if we get enough feedback, we could invest in that. I think more likely, though, if people feel strongly about that, it'll come in the form of an analyzer, where if people are really concerned about the kind of null safety of their attributes, they can do a little extra analysis to say, like, this is or isn't correct application of it.
So when the type is not nullable, let's say the input to the method, and there used to be a null check inside, that's basically redundant now, isn't it?
It's not redundant. That's kind of for developers to make their own decisions on. So if you look at, like, a public API, when you say that, like, the input is non-null, what you're doing is you're telling the developers who are calling you, hey, I don't accept null, please don't pass it. But there's nothing stopping it from happening. There's nothing stopping from someone just ignoring the warning, someone who didn't ever enable nullability, or some legacy code which has just never had the opportunity to do so. And for public APIs, we still recommend do the null checks, because you can't guarantee that people are passing you non-null values. This is just a guide for you and your developers to have the best possible interactions. Now, if you get to like private APIs, where within your own code, this is code within my code, like that is completely under my control, which is calling it, and I have full nullability checking enabled. It might then be like kind of the pragmatic choice to say, why am I doing the, like I've done all the work possible, I guarantee these are non-null, why am I spending the checks to do it? And that's a very reasonable thing to do.
But it doesn't tell you, well, this part, like analyzer or something, this part of code is basically not, it's redundant. It doesn't say anything like that?
No, we don't say that. We made an explicit decision to allow people to check for null. And to the point where if you actually have a non-null value, like if you have like string, input, and then you say, if input is null, and then you do input.toString, the compiler will give you a warning. Because it will say, even though you said that was non-null, you just proved it was null. So now you need to deal with the consequences.
So, and it's only checked at compile time.
Yes.
So with the reflection, let's say, I can still pass a null.
Absolutely.
Okay.
Reflection can pass null. People who have not annotated can pass null. People who have annotated and are just using the trust me operator and they were wrong, they can also pass null.
Thanks.
So, are there any more questions? I think we got about 4 more minutes.
Hi, so my question is regarding perf. So you were mentioning that there is a performance hit. So what did you measure on average projects? What's the performance hit when you enable this feature? And is it possible to parallelize it on modern machines, basically, to have it faster building?
I think when we did the initial measurement, so the performance hit is just how long does it take to compile your code. And I think what we found when we turned it on for Roslyn, it was somewhere in like the 3 to 4% like degradation when we turned it on everywhere. Once again, we're talking about 500,000 lines of code. We did that. And in terms of parallelization, it's already, the compiler is highly parallelized. We are very good at abusing your CPUs, and nullability just fed right into that, and it was very happy to do so. And I think when it was originally about 5%, and we actually used the kind of perf data to find the hot spots and fix them up. The expectation is that in most code, they're not going to know any difference. Like it doesn't really have any impact. Like we've turned this on. We check our compiler into Visual Studio every night, and the entire Visual Studio product rebuilds. They never like emailed us or anything like that. So, and we had a couple of times where we just turned it on to see what would happen, and there were no scary emails in my inbox the next day. It went completely unnoticed, and then we turned it off before we shipped. So, are there any questions? I think we probably have time for one more, and then I have to be respectful of the next speaker. Okay, right up front, and then I will go outside if anyone has any other questions. I'll be happy to kind of walk outside and answer them. I just want to make sure the next speaker has time.
Hello.
I can't see who's.
Here?
There we go. Thank you.
Is there any additions to Roslyn API when I want to analyze code via Roslyn, when the parameter is nullable?
Are you asking if in the Roslyn API?
Yeah.
Yes. So we the API surface now exposes, like as a part of iSymbol, there is now a member called like nullable annotation. And that will tell you both like what is the declared annotation, essentially like what did the user put in the code, and then if you use the semantic model, you can actually get the flow state. It will return both what did the user declare, and based on the flow of the program, all that tracking we showed you, what is the current null state of the object at this point in the method. We just changed, if you go and look for that today though, we literally just changed that API, I believe for 16.4. So it doesn't appear on iSymbol until about 16.4. Before that, it was in a more awkward position.
Thank you.
All right. Thank you, everyone. Like I said, if you have any follow-up questions, I'll kind of like stand outside, and you guys can, I'm more than happy to chat about this. Thanks again for coming out, everyone.